All right, so next thing we're gonna do, I'm just gonna do a cross product by hand with curves. Okay, so let's take that same function we had. Okay. T cubed plus 3t, t squared plus 1, 3t plus 4. And we're going to take r prime, r double prime, and then we're going to take r prime cross r double prime. Okay? So r prime's pretty standard, is 3t squared plus 3. We actually already did this. 2t, 3. R double prime is 6t, 2, 0. And then r prime cross r double prime is going to be the determinant I, j, k. R prime goes first. R double prime goes next. Okay. Play this game. Okay, math is a game. Okay, if you think of it as a game, it'll be more fun and you'll enjoy your life in engineering a lot more. Okay. I is what? Okay, those are positive, those are negative, right? Okay, so I is going to have 0, -6, plus j hat, that's going to be 18t, minus 0, plus k hat, that's going to be 12t squared minus 6t squared minus 6. So that's going to be -6, 18t, 6t squared minus 6. Okay. Let me put little hats on that one. Okay. So that's all you have to do. There's nothing really crazy about it. A couple of things that are nice is there's this nice little result. If r of t has constant speed, then velocity and acceleration are perpendicular. Okay, so what does that mean? How the heck does that come out? Okay, you may have seen this already, but constant speed means the magnitude of r prime is 0, right? Okay, so we're going to take, that's equivalent to saying the magnitude of r prime of t squared is 0. Okay, so this, though, actually means that r prime dotted with r prime equals 0, right? Sorry, constant speed means this is constant. Oops, sort of gave it away. I hate when I do that. Just kidding, I'm fine. Okay, so now I'm going to take the derivative of both sides here. but the derivative of a constant is 0. Okay, so I take the derivative of the left-hand side, that's going to be a product rule. So r prime dotted with r double prime plus r prime dotted with r double prime, so it's going to be 2 equals 0. But now, the dot product of two vectors is 0 when they are perpendicular. Of course, you could have a being 0, but if acceleration is 0, then you don't even have any speed because velocity doesn't change, right? You don't have any change in speed. So that's clearly true, okay? All right. Let's do one more problem. Let's take, this is number 58. Okay, and we have, at what points do the curves r1 of t equaling t 1 minus t 3 plus t squared and r2 of t equals 3 minus s minus 2, and s squared intersect. And then find the angle of intersection. Okay. So to find when they intersect, we're just going to have to set the x, y's, and z's equal to each other. Okay, so when do they intersect? Well, you would need t to equal 3 minus s, 1 minus t to equal s minus 2, and 3 plus t squared to equal s squared. Okay, so let's take a look at those first two equations. I'm going to write that as t plus s equals 3. Okay, and the other one I'm going to write as what? So negative t plus s. I'm moving everything over to this side, or the t over to this side. Oh. No. T plus s equals 3. So I was going to go as t plus s equals 3. Okay, now we're going to have to use this third equation. 3 plus t squared equals s squared. So I'm just going to plug, let's say, t equals 3 minus s. I'm going to plug that in to here. Okay, so 3 plus 3 minus s squared equals s squared. 3 plus 9 minus 6s plus s squared equals s squared. These s squareds cancel. So I get 12 minus 6s equals 0, s equals 2. So if s equals 2, t equals 1. Okay, so what are our points? We have, that's it. I don't even need to know the points. I just plug them in. So that's going to be what? The point's going to be, let's plug in t equals 1 to the first one. So we're going to get 1, 0, 4. I'm just going to check that that still works here. If I plug 2 in, I'm going to get 1, 0, 4. Good. Check. Now, their angle of intersection. I'm going to need to find the derivative at these points. So let's take R1 prime, 1, -1, 2t, R2 prime, -1, 1, 2s. I'm going to plug in these 2 points. I'm going to plug in t equals 1 and s equals 2 to find the derivative at the point, okay? So that's the direction in which these curves are pointing at that point in time, okay? So here we're going to get what? 1, -1, t equals 1 is 2. -1, 1, s equals 2 is 4. Now we have to find the angle between these 2 vectors. You remember how to do that? That's right, it's the dot product, right? So the angle, well, we're going to find the cosine of the angle is going to be R1 prime dotted with R2 prime divided by the magnitudes. So we're going to get, in the numerator, we're going to get -1 minus 1 plus 8 divided by the square root of 4 plus 2 is, I'm sorry, 4 plus 1 is 5 plus square root of 6. 16 square root of 18. Okay. So taking the inverse cosine of that, we're gonna get (54.73 degrees, which I'm gonna round to 55 degrees. Okay, I should have actually just gone to 54.7. Okay, because it said to the nearest degree. All right, that's going to be it for 10.7. I'll see y'all in the next set of videos.